Hello everyone. Today we're going to be talking about properties of logarithms. And so because logarithms are exponents, you can derive the properties of logarithms from the properties of exponents. So if you remember, if we have a to the m times a to the n, the product property told us that that is equal to a to the m plus n. The quotient property told us that if we're dividing those, we subtract the exponents, and then the power of a power property told us that we multiply those exponents. So the properties of logarithms look very similar to that. First, we have the product property, which says that if we have log base b of m times n, that is equal to the log base b of m plus the log base b of n. So for example, here I have log base 7 of 3x. So remember 3x, it's really saying 3 times x. So I can expand this by saying that this is equal to log base 7 of 3 plus log base 7 of x. The quotient property, just like it is for exponents, says that the log base b of m divided by n is the same thing as log base b of m minus log base b of n. So if we're dividing, we can rewrite that to say we're subtracting those logs. So for example, here I have log of x divided by y. I can rewrite that to say that this is equal to log of x minus log of y. And then I have the power property, and that one has log base b of m raised to the n power is equal to n times log base b of m. So for example, if I have the natural log of x squared, I can say this is equal to that exponent being multiplied out in front. So I have 2 times natural log of x. So I just take that exponent and move it out to the front to be multiplied with that log. So let's go through some examples of using these properties of logarithms. So directions: use the fact that log base 2 of 3 is approximately 1.585 and log base 2 of 7 is approximately 2.807 to evaluate each logarithm. So we're given log base 2 of 3 and log base 2 of 7. So we're going to use those values to figure out each of these 3 logs. So first I have log base 2 of 3/7, or in other words, 3 divided by 7. Well, the quotient property says that if I am dividing in there, I can expand this out to be log base 2 of 3 minus log base 2 of 7. So I'm only subtracting what's in the denominator of that fraction. And now I have both of those values. I have that log base 2 of 3 is approximately 1.585. And that log base 2 of 7 is approximately 2.807. And then when I subtract those, I get negative 1.222. Okay, this next one I have log base 2 of 21. Now in my directions, I don't have the value of log base 2 of 21. I only have 3 and 7. So I need to figure out how I can rewrite this 21 to be in terms of 3 and 7. Well, I know that 3 times 7 is 21, so I can rewrite this to say log base 2 of 3 times 7. And then that product property tells me I can expand this out to be log base 2 of 3 plus log base 2 of 7. And now I have both of those values. So I know this is going to be approximately 1.585 plus 2.807. And when I add those together, I get 4.392. Okay, now this last one I have log base 2 of 49. So again, I need to rewrite this in terms of 3 and or 7. Well, 49, I know that 7 squared gets me 49. So I can rewrite this to say log base 2 of 7 squared. And now I know from my power property that I can rewrite this log to actually have that exponent being multiplied out in the front. So this is equal to 2 times log base 2 of 7. Well, in my directions, I know what log base 2 of 7 approximately is. and that is 2 times 2.807. And so I get that this value of the log is 5.614.